So I thought I would start with a case study. So I found this off of Epilepsy Society, and this is the story of Casey from Fran, who's the owner's perspective. So I'll just read it. The first time Casey had a seizure, I thought that she had been poisoned. She was sick and shaking. I put my hand in her mouth thinking I needed to remove something toxic, and she bit me badly. I was mortified to see her like that and really panicked. So the question is, what's wrong with Casey? How can we help her, and how can we treat her the best way possible? So Casey has something called epilepsy, which is a type of brain disorder where abnormal firings in her cortex cause recurrent seizures. It's pretty prevalent in dogs, a little bit less than 1% prevalence, which makes it the most reported neurodevelopmental issue in dogs. And it's also very prevalent in adults, primarily children. The way that we diagnose epilepsy is through an EEG machine, which is that scan that you see on the right. This measures brain activity in the cortex, and we can analyze these patterns to see if there are epileptic spikes to give indication that there's some type of epileptic seizure. So one issue in diagnosing dogs with epilepsy is that their brains in a lot of ways are quite different than humans' brains. And cases that are reported and studied in humans aren't reported to the same degree as dogs. And because there are a bunch of differences in the way that our brain is kind of structured, you can't just directly take these definitions that have been classically seen in humans and transfer it onto dogs. And as such, we have fewer types of epilepsy reported, fewer benign variants reported, and we just have more general information right now for diagnosis. One of the other issues with diagnosing epilepsy in dogs is overdiagnosis. So on the screen, I have two different EEG scans. One is totally normal and one is really bad, but they look pretty similar. And to an untrained eye, you might not be able to tell when reading the EEG scan. On the right, we have a 6 Hertz epilepsy, but on the left, we have something called hypersynchrony, which is just a super common variant. And one issue is that when we're kind of selectively looking for these epileptic patterns and training our eye to look for these epileptic patterns. And often this can lead to us over finding these in places where they're not and overdiagnosing epilepsy. And we know for a fact that in humans, at least, epilepsy is an overdiagnosed condition, presumably for this reason. Dogs are being recorded for 4+ hours, humans for 12+ hours. So we'll find a lot of patterns that sometimes look like epilepsy, but aren't necessarily. So why is this important? This is important because treatment isn't benign. The drugs that we give have side effects, and the surgery can be very invasive. And we want to minimize harm. And overdiagnosing and overtreating can cause these canines a lot of harm. So my summer project looks at these benign EEG patterns. Before I even started my project, people at Dr. Fiona and some of her master's students noticed that there were these benign patterns that they didn't have a way to classify in dogs. And again, one of the issues when we see these benign patterns is that they're misdiagnosed in these dogs as epilepsy. So I have 2 here from a dog. This occurred while he was falling asleep and getting out of sleep, awakening. And so the question kind of leading my research project was, how do these relate to what we know in humans? So my task was to first create some case definitions or some definitions of some patterns that we see. The first that I looked at was hypersynchrony. Hypersynchrony occurs while a human is falling asleep or waking up. So it's associated with like coming out of sleep. Some background activity that you might see is muscle movements or eye movements while that person is starting to fall asleep or starting to wake up. As we see here, the voltage is higher than the background, at highest around 300 millivolts, but it can be lower depending on the case. As I showed in my last example, the amplitude was a lot lower. And that's partly because of the differences between dogs and humans. So dogs have very thick skulls. And because of the way that we test dogs for epilepsy, we won't be able to see such a sensitive amplitude. The frequency is 4 to 6, which is in around the theta waveform. So as we see, like there's slowing going on here. That's kind of what it means. And then onset for humans is basically as an infant. And this has to do with myelination of the person. Because we're not fully developed as an infant, there's some brain activity that would be abnormal if we were an adult or would be indicative of brain damage. And then hopefully we see these kind of activities stop or regress as we age out of it. So one question going into this study was, is this activity indicative of dogs having less brain development than humans? So would we see this in adult dogs as well because they're less developed, for example? Another important thing to mention is that there's a couple different kinds of hypersynchrony. There's hypnagogic, which occurs while the person is falling asleep and drowsy, and hypnopompic, which occurs while the person is getting out of sleep. Another type of rhythm that I looked into is Syngagic. In a lot of ways, this overlaps with hypersynchrony in the patterns and the frequency and the amplitude and when we would see it, so in that state of drowsiness. A couple of the ways that we distinguish them are where in the EEG we see this the most. So for Syngagic rhythm, we'll see this most in the central region. So like F4 and C4 here. But then in hypersynchrony, it's more generalized, for example. Another one that I looked into in humans to define is birds, which occurs in the temporal regions of the brain, like over here, and it's often lateralized to one part of the brain. This occurs, however, primarily with adults with brain damage, along with infants. So this can be indicative of other issues, while the other two that I described are purely just developmental normal variants. This, although it isn't epileptic, it can indicate there are some other brain issues going on. Yeah. And then I made a little flowchart describing a bunch of different forms of benign patterns. So you could, it's kind of like one of those 2000s Cosmopolitan magazines where you can go down through the flowchart and figure out which benign variant most represents what you could have, who knows, but yeah, so I think it's a good way to kind of condense the information. And going back to a slide I put up before showing some of the patterns, I actually had a meeting this morning where we talked to someone who is an MD about this, and so I have some updates actually about the first question before my research even started, which was, again, what are these? Do these fit any of the definitions we see in humans? And we found that these are probably some kind of theta bursts that occur in drowsiness, so not exactly hypersynchrony or syngonic, but something more general. And then another one that I found that I thought was pretty cool was sawtooths, which I didn't do a formal definition on, but it's a form of REM sleep. It's like a REM sleep pattern. So when we're like awake, we have certain brain activities that can kind of be mimicked when we're in REM sleep or rapid eye movement sleep. So a lot of similar brain activities. So that's why we see this increase in amplitude and increase in activity over here. And this is, again, in a benign variant. Sometimes that's confused with epilepsy. So that's kind of interesting to see. One Health approach. So how does this fit into a One Health model? So there's a couple ways. The first way, like I mentioned before, by comparing human health to animal health. we can refine these definitions and find cases in canines or other animals that fit these definitions so that we can better help and treat these dogs by improving diagnosis. And there's also kind of a reciprocal action here because, so right now, most models for epilepsy are rodents and sometimes small cats. But by showing similarities between canines and humans, we're able to use canines as a model for epilepsy in humans. And if they are really, if we can show that they're developmentally at a younger age, they can be a really good model for like child epilepsy, for example, which is unfortunately very common. So there's kind of like a reciprocal understanding more about humans helps dogs, but then also understanding more about dogs can help humans as a model. Environmental health is a little bit harder to tack on. There are a lot of environmental factors that can affect epilepsy, pollution, there's like nutrition can affect epilepsy. And there's also kind of like psychosocial health, like I mentioned in the case study at the beginning, how the owner was very distressed by seeing her dog in pain and panicking and didn't know what to do. So there are there are connections to a kind of a broader environment, but definitely my project looked more at how human health and animal health are intertwined and how they can reciprocally kind of help each other. And yeah, that's my presentation.
Thank you so much, Rachel. That was amazing. So now we're going to move on to the discussions. I have some questions that we can kick off. So I don't know if you mentioned it, Rachel, but is epilepsy in dogs an inherited condition, or is it more of like a random mutation and they're not sure how dogs become epileptic?
I'm not sure. I'm not sure if it's quite known if it's inherited or not. I haven't done any background research into that, but I do know epilepsy in humans have like a hereditary component, and because their profiles seem to be similar, I would assume that there would be, but there's definitely like non-genetic environmental factors, not all of them that are actually known, that can contribute. A lot of actually the causes of epilepsy in dogs aren't, as far as I understand, aren't fully understood. And even the types of epilepsy are still being kind of researched. So it's kind of, there's a lot to learn.
Yeah, absolutely. As someone like myself, I know very little about epilepsy, and I feel that most of what I've seen about epilepsy, especially in humans, is probably what I see in the media, which is like triggering lights or like almost like strobes. And I was wondering if dogs have a similar trigger, or if, I guess you might not know, and that's okay. I feel like I just don't know a lot about the triggering environments.
That's a good question. I'm not sure. I know most of the time these disorders happen while dogs are sleeping. There's another kind of seizure called an absence seizure that's actually currently being studied by a grad student at the lab, which occurs during hyperventilation. So those are the two cases I know about. The variants that I studied occur mainly during drowsiness or sleep. So those were the forms of like seizures I looked into, because that was mainly just the state I was looking at, but not too sure.
Yeah, it's definitely a very interesting project, and I definitely haven't heard of anything like it. So good job. I'm glad. Has your experience working this summer, obviously, I assume from home, how different do you think it would have been if COVID-19 hadn't impacted your research? Like, would you have done anything different and had more hands-on work?
Yeah, so my entire project would have been different, actually. I would have done a different project that had to do with therapy, and a couple different projects that had to do with treatment options. And this project looks at overdiagnosis, but the project before would have looked at certain ways that epilepsy are underdiagnosed, and like treatment options. So we had to completely change to like a prospective study, just because of the constraints of COVID. But it's still interesting research, and I'm still really glad that I was able to do it. even despite the fact that the circumstances were so unprecedented. So.
Yeah, absolutely. I think everyone on this call can probably agree that everything is very different, but it's good that we're adaptable, and it's a strength for sure. So I'm very glad that your research is still really fulfilling. I see no one has any questions, so I'm still going to ask you another one. I'm so sorry, Rachel. I know that the summer is kind of wrapping up soon, but I was wondering if a communication piece would also be potentially integrated into your summer project, kind of letting the general public or people who have pets know more about canine epilepsy, if that was a component, just kind of getting the word out and potentially being able to generate more data or just bring awareness to this topic. I didn't know if that was a part of your project as well.
Yeah, that wasn't a part of my project, but that's, I think, a really interesting idea. I could, think about it and see if it can relate. But yeah, definitely to kind of bring awareness to the owners. More so, I think what we're talking about now is potentially looking at its applications for human epilepsy. So it kind of said at the end that right now models are like more rodents and small cats. And like the goal is to use animals that more and more approximate humans as like models to represent epilepsy. So this is kind of in the human world as a way to kind of progress into using more refined models for like epilepsy research.
Yeah, absolutely. So we have a question here from Simon, who says, what do you think is the most important future direction for research in this area?
Ooh. What's the most important future direction? I think it's important, number one, to look back do a retrospective look at cases that have been confirmed, knowing the knowledge that we do about benign patterns, and hopefully the more that we learn, because I think it's important that dogs that were misdiagnosed would be treated sufficiently. I think that's one of the more harsh realities, the fact that there are dogs on medication getting treatments that they don't need. So I think that's an important step. And I think it's also just an important step to categorize more patterns in dogs. So I kind of said before, but about seizures being classified, but right now, really, it's just like, do they have a seizure? Do they not? It's not really characterized well enough to know what kinds of seizures. So more research into that should be known. And then, I think just there needs to be more data right now. So when the lab starts running data, I think that's important to confirm, this kind of more prospective data.
Yeah, I think it's definitely tougher when you don't have like a single virus or bacteria that you can just isolate and figure out that's the main cause. So it sounds like you have a good handle on where this potentially is going. And we have a couple more questions. So one is, what is something you learned from this project that surprised you the most?
I think it surprised me how similar in a lot of ways dogs were to humans. I've always kind of assumed humans, a lot of their like neurodevelopmental issues were pretty unique. So I think that was something that surprised me, seeing how many parallels there were, especially like some of these things are more higher order. Like some of these, I don't know, like some of these issues it really opened my eyes to like the similarities, I guess. I'm someone who, even though like I'm obviously this is the OVP, which is veterinary hospital, like I'm very interested in like human disorders. So I thought it was really interesting to see like the comparisons in that way, I guess.
Yeah,
like,
absolutely.
I didn't realize like how similar, I guess, some of these like issues were, especially because they're related to development.
Yeah, it's really cool that you guys can potentially use a model separate from rodents, because the majority of us know that rodents are not the ideal, but definitely the go-to model for human disease and condition modeling. So that is really, really interesting. And I have another question here that says, is the genetic element linked to these epileptic pattern susceptibility in canines? I'm not sure which genetic element, but yes.
So I don't really know if like I believe because there are genetic elements in humans that there would probably be some in canines. I'm not too sure. That wasn't what I managed to study in this project, but I know it relates to age. So younger canines are more likely to have epilepsy than older canines, and it's there's a lot that we don't understand from what I understand. But yeah.
All right, and Sydney, you can go ahead.
Hi, Rachel. I just want to say amazing presentation. I don't really know anything about this research area, so it was very enlightening for me, and I learned a lot of new definitions that I didn't expect to know after this call. So my question is that you mentioned it was difficult for you to incorporate the environmental pillar into your work, and I was wondering if, given unlimited resources and time, how you think you would go about incorporating the environmental aspect into this research project. Like you said a lot about these benign variants happening while they're sleeping. Does the place that they sleep impact how often they occur? Stuff like that.
Right. I think that'd be a really interesting question to look at, to see like we know like sedation, for example, affects how epilepsy occurs in dogs. So yeah, I think that like there is definitely some kind of environmental aspect to these seizures that would be interesting to look at. How I would go about that, as this is a prospective study, I'd have to rely on the data reported in the case studies, or sorry, in the case reports, which sometimes can be limited. So it's hard to build a whole picture based on what we see there. But yeah, it would be an interesting question because we know that things like pollution and nutrition affect epilepsy. So there's, I mean, in humans at least, there is a huge environmental component to epilepsy, and we assume as well in dogs, although sometimes the causes aren't fully known. So I think it would have to do more with another project, more on prospective study, where we're able to get all that information beforehand, because right now we're kind of at the mercy of what the people before put in the reports.
Right, that makes a lot of sense, and completely understand when you aren't in control of the data that you collect, and or you have to rely on what's practical for the people who are collecting that data and sending it to you. So that's very cool, and I'm excited to see how you and your research team apply this research later on.
I have another question. How do you think this summer research project with a One Health approach will impact your final year at the University of Guelph and your future goals as a researcher or a scientist, and whatever that may be going forward?
I've always known I've been really interested in brain disorders. That's something that I've always wanted to, go learn more about in my studies. I'm currently applying to med school. I want to go. I'd actually either want to go into neurology or psychiatry. So I'm really interested in Alzheimer's and schizophrenia as well. So I think I'm really glad to get some experience. EEGs are actually something I've always wanted to learn how to use. I thought they were so cool. It was actually the reason why I was really, really, really wanted this, hope to get this project, because I knew we were doing work on EEG machines and analyzing EEGs, and they're used for so many different brain disorders. So I'm really happy that I got a chance to use them. And I would compare using EEGs kind of like reading tea leaves. but scientifically accurate tea leaves, because they're scientifically accurate, but they're also like, you're like, oh my gosh, these are just squiggles. But then somebody who knows more will be like, oh, it's this, this, and this, and this. You're like, what? I just see lines and spaghetti everywhere. So it's kind of, it's really interesting. It's different than some other machines like an MRI or something, because it's like literally all just lines. You just kind of have to understand what they're saying, and it's kind of, yeah, it's really interesting. But I'm really glad I got experience using EEGs. I think that's one of the things I'm really happy taking out of this project.
It definitely does look like big spaghetti lines to someone like me who's never looked at them before. So I found your presentation very helpful. That's why we like these research bites, so that it's not all intimidating for everyone. When we look at big research, it's hard sometimes to take that first step in understanding. What course are you looking forward to taking next year in the online format?
I haven't. So one course I really want to get into, but it was restricted to neuroscience majors. I'm a neuroscience minor, is neuropharmacology. So I want to see if that opens up. Another course I'm looking forward to is I'm doing a research project next semester that I'm looking. It's not really in my field completely. It's like with a neuroscience prof, but it's like more cognitive neuroscience. So, but he looks at EEGs as well, so that's kind of why I kind of have like a specific interest. Not specific, but I don't know. I'm again, like, I really like learning about brain disorders and kind of combining like my biomedical science major with my neuroscience minor, and something within that middle is always really interesting to me.
Yeah, absolutely. These unique perspectives will help you. They will never hinder you. They will always help you. And my final question, and then we can wrap this up if no one has any other questions, is how are you still finding joy working from home during the COVID-19 pandemic? Wherever you are.
I have a really wonderful cat who's staying with me, so she's always great. I really like knitting. I really like going on walks. Sometimes I bake with my roommates. Try to keep myself busy. I do some like volunteering just to keep myself sane. It's good.
It's very good. It's the most important part of the summer quarantine. I suppose it's not really quarantine anymore, but if no one else has any questions, I think we can wrap up for today. Thank you again so much, Rachael, for that wonderful presentation and answering the oodles of questions that followed. You did awesome. That's fantastic. All right, so thank you, everybody.